Hey YouTubers, what's up? My name is Justin. I'm going to be helping you through this one. Now the general idea is to deploy a Jupyter Notebook Server into production. Now the easiest way to do that, in my opinion, is using Docker containers. Of course, we use Docker to make sure that we control all of the environment that's actually running Jupyter. And we do so in a way that's just pretty simple. It's just one recipe that we use that goes forward, right? But one of the biggest downsides of using Docker is it's ephemeral. That is, in Jupyter, we create notebooks all the time, but Docker is ephemeral, meaning the notebooks that we create, the next time we deploy a new version, those notebooks are going to be gone unless we do something about it. I'm going to show you how to do something about it in this one as well. So make sure you subscribe to get everything. I'm going to be doing a lot more stuff related to Docker and Jupyter because I think they're both fantastic concepts. And then, of course, we're going to be deploying this onto Heroku, which is just a hosting service for Docker containers. But really, once you know how to build the Docker container, you can have it hosted in a lot of places. And we'll talk about that a little bit more too. So let's go ahead and jump right in. Hey there, welcome to Jupyter and Docker. In this one, I want to actually show you why we use Jupyter and why Docker is so important for that. Then, of course, we're going to deploy it on a hosting service called Heroku. So just to recap that, we're going to be using Jupyter Notebooks to make a Jupyter Notebook Server. We're going to deploy it on Heroku, and all of that is because of Docker. Now, Docker gives us control over the environment that runs the Jupyter Notebook in a way that other things just don't. Containers are amazing. So if you haven't done Docker containers, I highly recommend it. So let's actually take a look at what it is that we're going to be building. So this is the Jupyter Notebook Server that we have. Now, if you're familiar with Jupyter, this just looks like a normal Jupyter Notebook server locally, right? The biggest difference here is that I can actually log out and log into this, and it's on a live URL. So depending on when you're looking at this, this might be accessible to you with the exception of the actual password, right? So you won't necessarily be able to come in here without the correct password, which may or may not change over time. So the key thing here is that I can actually create what's called a Jupyter Notebook, which is just a Python notebook in this case, right? So I can call this Hello World. And of course, if you're familiar with Jupyter, you're already like, I know how to do all this. But if you're not, this is probably new to you and maybe pretty interesting. So in this, we can actually import some of the packages that I installed by default, like Python requests. This is not built into Python. It just is a package that I installed. So you can do stuff like request.get and something like http bin.org/get and then print out r.status code. Stuff like that, right? By default, it's in there, which is really cool. So if I close and halt this, maybe I want to save it first actually with Control S, I can do all the things I need to in Jupyter. Another part of this is I can actually come in here into a running terminal, or I can create a brand new one, right? So let's create a new terminal. And now I actually have access to the terminal or a bash shell, right? So I can call curl. I don't have curl. So maybe I need to install it if I need it. But I do have Python and I can import stuff like pandas. I can do all of the shell related things on here. Well, you would import pandas as PD, as most people do. You can import TensorFlow as TF. Every package that you might want to have, you could totally have on our Jupyter Notebook. Now, it's not going to necessarily be incredibly fast. In my case, I didn't actually provision that many resources to this particular notebook server. But it does work, and it works really well. Okay, so there are some huge caveats about using our own Jupyter Notebook Server. The first one is the inherent nature of a Docker container. That is, it's ephemeral. It's going to go away. So the next time I build the environment for my Jupyter Notebook server, I actually need to store all of my old Jupyter Notebooks. I'm going to show you a technique on how to do that. The other part of this is Heroku doesn't have GPUs. This is a good and bad thing. So if you're trying to do machine learning, you're probably going to want to have some GPUs. If you're not going to do machine learning, this is completely fine. You can actually increase the power of the CPUs that you have available to actually run a more robust server on here. So you could actually do a lot of development, if not all of your development, on this Jupyter Notebook Server. And that includes even Django. Like, you can actually build Django applications using Jupyter. That is where I kind of say, like, maybe you shouldn't build your whole Django application using Jupyter. But instead, you should do stuff like web scraping, right? So web scraping is really good for Jupyter, as we just kind of alluded to here, right? So you could totally build in this long sort of story that's going on in this notebook that anybody else can use. So the caveats about this are, number one, Docker containers are ephemeral, which means that all of these notebooks, when we rebuild the environment, are going to go away unless we save them locally first. Next, the lack of GPUs. So this is where I have to tell you that there is an alternative that is provided by Google. They haven't responded to this. I would love for them to, but they haven't. So colab.research.google.com. This has access to GPUs, and your Python notebooks are persistent. They update the environments all the time, but the notebooks don't go away. They don't just delete, right? They have their own kind of issues in of the notebook itself, but the notebook will always stay there. So those are a couple things related to what we're going to be doing. Of course, if you have any questions, please let me know. If you've never done something like this before, just keep in mind that you will want to have Docker Desktop and the Heroku CLI installed locally. Otherwise, you're probably not going to get as much benefit out of this as you potentially could. Those are the blog posts I'm going to be going through, so feel free to jump and follow along there. And of course, if you get stuck, this is the GitHub repo that we will have all of the final code. It's already there to actually build this thing out. So the first thing I'm going to do is actually set up my local environment inside of VS Code. So I am going to go ahead and add a folder to this workspace. I'm going to open one up. And in this case, I'll call this CFE-Jupyter. And inside of here. And then we'll save this workspace as CFE-Jupyter. And then we'll go ahead and activate the virtual environment. So I like using pipenv. So pipenv install Jupyter, and we'll be using Python version 3.8. Okay, so I'm going to let that finish installing. All right, so my virtual environment has installed. Let's go ahead and activate it, pipenv shell. And I'm going to just run the Jupyter Notebook Server to make sure it's running. So Jupyter Notebook. And naturally, what this will do is automatically open up a brand new server for me. And there's a couple things to note. Number one, we see the pip file and the code workspace. So it already has a working environment for me, and it's just based off of the directory that I'm currently in, of course. But number two, it actually didn't prompt me to log in, right? So if I log out and go to login page, it says token authentication is enabled. So this is the very first thing that I actually want to change. So in order for me to do this, I actually have to create my configuration that Jupyter has. Now, this may or may not already be on your local system, right? So your local system can have Jupyter configuration by default, right? So you can have a lot of defaults on your local system. We're actually going to be leveraging that same concept inside of a Docker container. So let's change the default configuration for our Jupyter Notebook Server. So all I'm going to do here is add a password protected Jupyter Notebook Server that we can work with locally. So to do this, inside of my projects directory, I'm going to go ahead and add a new folder called conf for all configuration that I may need in this project. And I'm going to add a file for Jupyter itself, and it's going to be jupyter.py. Now the first thing I'm going to do is just use C equals to git config and parentheses. Okay, so this will be passed in to Jupyter by default. Okay, so next what I'm going to do is c.notebookapp.password, and I want to set this equal to a password. Now I can't actually just put a password in here. I have to use a hashed password. So luckily for us, IPython, which is installed by default when you actually create a Jupyter notebook or install Jupyter itself, we actually can use this command to call something else for us, which is from notebook.auth import psswd, which is password, and then psswd, we actually call that. So you could do it with IPython or just Python itself, and then print out that result. IPython just doesn't need that print statement. That's pretty much it. Okay, so this reference I'll come back to. You can definitely find it in many different ways. But let's go ahead and create our Jupyter Notebook Server password. And I'm going to go ahead and type out ABC. You will not see the typing here. And the output is this hash here. Okay, so literally the password is ABC. I did not do anything different. That's all I did. So I'm going to paste this in here. And it needs to be a Unicode string, so just put a U in front of it. And now we have new configuration. Okay, so the path to this, of course, is conf jupyter.py, just like that. So to actually run our project with this command, it's really simple. It's Jupyter Notebook notebook config, and we'll set that equal to the path of conf and jupyter.py. Okay, so this should change how our Jupyter Notebook runs, in the sense that notice that there is no token authentication here anymore. And it is serving this from this directory, which is cool. And so if I see the Jupyter Notebook that came out, this is it right here, right? So it's real simple. I just type out ABC, log in, and it gives me that same look at the Jupyter Notebook. Okay, so how did I know that this was the parameter? Well, I've done it a number of times, but that's actually not how I figured it out. So go ahead and create a new terminal here. And what Jupyter allows us to do is actually change a lot of configuration options. So you're going to want to, just create the general config that comes in to Jupyter by default. So we'll go ahead and say Jupyter Notebook generate config, and this will actually create your configuration. Oh yeah, I should probably activate the virtual environment first. Okay, so now that I've got that activated, let's go ahead and run it again, hit enter. It's asking me to overwrite this, right? So this is the default configuration. So if you change this in the past and you change the system-wide one, perhaps you don't want to overwrite this, right? I just did this, but the reason for it is because you don't want to actually work off of the system-wide one for your local development system. You want to work off of a local one like we just did. So I'm going to go ahead and override that default and then open this up with command click in my case, or control click if you're on a Windows. And here's all of those configuration options, right? So you can scroll down in here and find everything that you need to find, everything that's related to actually changing how your Jupyter Notebook Server works. Now, of course, in that blog post that I mentioned, well, here it is right here. I actually give you all the configuration that you need for your particular project. So you can actually just go ahead and copy this. The only exception that you're going to want to change is the password one, which is why I talked about that first. So we paste this in here, and I'm going to go ahead and just put my password in to what was here. And we can talk about some of the other configurations in just a moment. I will leave the notes for generating that password in here as well, which are also on that blog post too. Okay, so the things that are happening here, well, they are pretty self-explanatory. The notebook DIRS one is going to be the root directory that we want to work off of. Allowed origin is when we actually go onto a Heroku, app itself, or we have a public IP address. Either one works. You could also put the IP address here. So additional configurations for the web app itself. Next, we actually need an environment variable for the port it's going to be running on, right? So when we actually go into production, we need this port to be set by Heroku. So that port right there is going to be set by Heroku or our server. This isn't always the case, but in the Heroku case, it definitely is. And this is actually how we're going to go ahead and change that. We're going to do it by using an environment variable inside of Docker, which we'll get there too. Allow root, this is not often recommended, so you can say false in your case if you'd like. For me, I don't see any reason why not to allow root, because this is my own personal project. I'm not letting anyone else use this. But if you don't need to allow root, then definitely say false. And then also password change. If you don't want to allow this to be changed at any time, then feel free to say false there. I actually think it'd be a good idea to say true here, because, you know, it would probably be better to have your password not stored in a document like this, even if it's hashed. And then the final thing is the actual port that we want to redirect to. In this case, we are not using HTTPS necessarily, so we add this redirect port in here as well. Cool. So that is, generally speaking, what's going on with the configuration. But there is certainly one more thing I need to do that we can see, and that is creating our root directory, as in, where do you want this thing to go after you actually log in? So I'm going to call it MBS, and of course I want this in the root of my project, so right next to conf. So we save that, and now let's go ahead back into Jupyter itself, Control C to close it down, keeping that conf going, hit enter, and what we should see here now is if I refresh, now I've got my notebook list is empty. So the root of this project is now empty. It's actually in this notebooks here, which is pretty cool. So that's some of the basics of the configuration. So let's go ahead and keep going. So now when we actually bring this into production, we have to remember that the state of Jupyter notebooks, or the actual notebooks themselves, is going to be temporary. That is, if we rebuild our application and then redeploy it, all of those notebooks will be gone. So we need a way to actually handle that challenge. So inside of Jupyter, I'm going to go ahead and create a new Python notebook here. And this one is going to be called, well, I'll call it Pack It Up. And so all this is going to do is make a zip file, and it's !tar chvfz notebook.tar.gz star. Okay, and if I run this cell, now Windows users, unfortunately this may not work for you. I have not tested it there. This will work on your Docker container when we get there, but I'm just wanting to illustrate the point here right now. Mac and Linux users, obviously it's going to work. Okay, so here we go. What I created here was a new tar file, which is a zip file that saved all of those notebooks. And we can see this by creating another notebook, and we'll call this unpack it. Okay, so !tar -xv -f is in file, notebook, we called it notebook.tar.gz. Okay, so we run that, and it unpacks pack it up. Okay, so I don't actually know, it's hard to tell if it actually did anything there. So let's close and halt pack it up. In fact, let's delete pack it up altogether. And let's run the unpack it again. And what do you know? What we should see in here, we reload it, is pack it up is back. And we've got unsave changed. So the original thing did not save. Maybe I didn't save it. Let's try it again. And notebook2.tar.gz. Okay. So let's save this again. Oh, I need to add a star here. So this is using the current directory, all files in the current directory, which is now 3 files, including the other notebook tar. Okay, so we save this. And again, I'm going to go ahead and delete that one. Close it out up here. And then unpack it again. Uh-oh, that went away too. Haha. So this is a good example of how the ephemeral nature of this is going to actually happen in Docker. I just tried to simulate it with how we're going to do the zipping and unzipping, right? But actually, we're going to be using the zipping and unzipping to keep these files as well. And I'll show you that right now. So we do !tar -xv -f notebook2.tar.gz. We run that. That gives me these files back, right? So unpack it will probably either be empty or not. It's hard to say. I just resaved it, so now it's not going to be affected at all. But pack it up, we did delete it, and now it's back, and there it is again, right? So it's actually now listed with that original code. So in that blog post, we actually combine these into being load and unload. So I'm going to make a new one. I'm going to delete all the other things. So I'm going to call this load, unload, and really just save this. Okay, so let's go ahead and delete everything else that we just went over. And save this one now. Unload, meaning zip all the files in the current directory. So this is unloading what's going to be on the server. And then loading will be what's reloading on the server later, right? So we save that, and it's only one file. And let's go ahead and just rename this now to 2, just to make sure it's working. And now I'm going to call this load. And I run that, and it gives me local unload. And there it is. And it has that original code. Okay. So yeah, you could use Git. You could absolutely use Git and version control and run some commands to Git. But the nice thing about this is all I need to do here is download that tar, and now I can just upload it or unload it, right? Either way. So I'm going to go ahead and delete these two things, or rather keep the tar and keep load, unload, and just delete the other one. Okay, so now I just have these two files in here. So when we actually build our Docker container, we'll have this load in here that will absolutely be able to load that tar. And this is going to make a lot more sense once we go into production. And I'll show you a few examples of how the Docker file or Docker containers will fail when we go into production for these notebooks. But this was just a simple way to me on how to load and unload all of these things. All right. Looks like I didn't delete every file. That unpack it is still there. So perhaps it's in the load, unload, I don't know. But for now, we're going to leave it as this. And then we need to create our Docker container. All right, so let's go ahead and create our minimal Docker file. And this is really minimal. So we want to come into the root of our project, create this new file here, and it's just Docker file. And then we're going to go ahead and use Python 3.8. So from Python 3.8.2 slim, and then env app _ home, and that's app, and then workdir, and this is $ app home. Gotta love VS Code and its code completion there. We want to copy everything from the current directory on over. And then we're going to go ahead and run pip install pip and pip env -- upgrade. Of course, I need pip env to install my pip file, but if you weren't using the pip env, you could totally use a pip file and just run pip install like, -r and requirements.txt. But of course, I'm using pip env, so this is not relevant for me, but I will leave it in case it's relevant for you. So pip env install, and then it's --skip -lock and --system. So I want it on the whole system and any dev dependencies I may have. And then finally, I'm going to have a command for my entry point. Docker loves double quotes, so use double quotes. That entry point is going to be in scripts entrypoint.sh. Since I'm writing this now, I'm going to go ahead and create all of the things for it, with the exception of what's actually going to go in that entry point, which if you're familiar with Docker, it's going to be super easy as to what's going in there. But let's go ahead and just a little bit more with this Docker file. First and foremost, we want to get the smallest possible image we can use. So if you're not familiar with Docker, every time you run it and build it, it creates an image for you. That image can be reused anywhere. So I could essentially turn this Docker file into a brand new image and call it something different. Let's call it like, CFE Python or something like that, which would have all of these things done first, right? So the Python slim image really just narrows down the size of your Docker container, and thus saving a lot of time in building and pushing and doing all sorts of cool stuff. So this is that minimal container that we need. That's it. Pretty cool, huh? So let's go ahead and actually create the entry point now. All right, so let's go ahead and write out that entire entry point.sh. It's just hashtag exclamation mark /bin/bash and then /user local or usr local bin Jupyter notebook -config equals to, well, what's the configuration file? Of course, it's in conf and Jupyter. And conf/Jupyter.py. Actually, we don't need those quotes there. It's redundant. Okay, so this is an entry point script that will work inside of Docker, but may not work on your local system. So if we actually activate the pipenv shell and try to run this, so Windows users, I'm positive you probably won't be able to run this at all, but Mac and Linux users, let's go ahead and try this. So chmod scripts entry, or rather entry point.sh. Of course, plus chmod plus x means that we can actually execute this. So let's execute it with /scripts, and then we get this error, right? Well, part of the reason for me is I don't have Jupyter on my system as a whole, so this is not actually where that's located, right? But when we use the Docker file, it's going to install it globally, so this entry point should absolutely work with that. Of course, we need to test that when we build it. The next few things are these commands right here. And of course, conf is where Jupyter, the actual configuration that I created, Jupyter.py is. And it's / because this is going to be in the root of the project, right? So Dockerfile itself is in the root of your project, but then it also tells us that we want to work in the work dir of app, right? So when I actually build this Docker container, we'll take a look at the Docker shell itself to see exactly how the code is laid out, so it's a little bit more clear in your mind in case it's not right now. Because if you haven't used Docker enough, it might not be. All right, so let's go ahead and build our Docker container. So it's simple, Docker build, and then we tag it where we want to tag it. In my case, it's cfe-jupyter, and then the actual Docker file that we're going to use, which is on the same root as this right here, and then a period at the end to build the current directory. So this should take some time, especially if you've never done this before for this tag or for the actual entry, the image that it's inheriting from. It could take a good amount of time to actually build this and be fairly large in size potentially as well because of what it's inheriting from. You might have to build all those things. So it's a number of things that it needs to do. I'm going to let that finish building and then we'll come right back. So while that is building, I will add a script in here under my scripts command directory called d_build.sh. So what I like to do is actually keep track of how I build my Docker containers. More specifically, the tag that I end up using for it, right? So inside of d_build, I usually add docker build -t cfe-jupyter and then -f Dockerfile period, right? So the exact same thing that I just had, I bring it into d_build.sh. And if you're on a Windows, all I do is d_build.ps1. ps1 is a PowerShell command. It's essentially like the shell command, but this is PowerShell. Kind of different, but accomplishes the same thing because the Docker command line interface is the same across all systems, which is super nice. But now that we've got this built, let's actually go ahead and take a look at this inside of the Docker container itself. So what I want to do is docker run -it, and then the tag itself, so cfe-jupyter, and then we'll do bin/bash. Okay. So what bin/bash does is it doesn't actually run the entry point. Instead, it allows you to jump into the shell of this project, as in the operating system, the image. It's bringing us in there so we can see what's going on. Notice if I do pwd, no matter what system you're on, right now you're using a Linux server, right? So if you're on a Windows, this is Linux. I'm on a Mac, it's Linux. So once you run docker run bin bash, you're now in a Linux server, you're in the Docker environment. In this case, I have a Docker server or a Linux server running. Perhaps there's other kinds of servers, but for me, I'm in a Linux server, so I can pwd. And I see the root of my app here, right? So it actually has everything from my local system in here as well, which your system may or may not have. But while it was building, I actually created a couple scripts. Those aren't in here. Actually, there should be no surprise to that fact because I added the scripts after I ran the command to build it. So whenever you make changes to your code, you have to rebuild it. That's just one of those tenets. Okay, so we have that entry point here, right? Of course, if we look at the Docker file, we see that that is actually being called, right? Obviously. And we can call this in the root of our project too. And what we see is it being run. Now, if I try to go to this URL, it's not going to work. There's a part of the reason is because I don't have the actual address of this image and how it's running. The other part is this is not how you should run your notebook server anyway. So let's go ahead and exit out of here. And let's go ahead and run it by creating a new script in here. So we'll do drun.sh. So the running script is, well, it's actually not that hard to do. So first and foremost, it's docker run and then --env port equals to the port we want to set. So I'll explain that in a moment again. And then we do -it-p, the actual port that we want to expose and the port that we want to run from, and CFE Jupyter. Okay, so the actual tag itself. So we save that, and if you're on Windows, just make a PS1 version, chomod +x, and scripts drun.sh, and scripts drun.sh. Okay, so this will actually run our Jupyter Notebook Server. And of course, if I go to this URL, I'm probably going to get something like this. Okay, so let's go ahead and go into localhost. Now it's running. I do want to make sure that I'm using the correct port, right? Or that this is actually coming from Docker itself. It looks like it is, but I'm not positive. So let's go into ABC and let's create a new file here. And I'll just call this another one. Okay, so what we shouldn't see in VS Code is a new file called another one in our notebooks folder. And if we go in there, nothing, right? So this is the exact reason. If I print hello and save this, this is the exact reason why we have this load unload thing. Unload will remake it, right? So we run that. And now if I download this actual directory or that tar, it will be those original files here, right? So what we saw on the unload is it actually grabbed and created all those things. And now it can actually run and download this. And then with that one, I would just replace what's currently in there. And then we would just repeat that cycle as we make changes. So that's actually pretty cool if you ask me. We now have a way to build it and run it. So oftentimes when I have this command of build and run, I'm usually doing both simultaneously. So I also create a command called bnr, as in build and run, or I type out build and run completely. But you know, I think in the repo you'll see it as build and run, or you just call one called run, or just, you know, come up with your own style, whatever it is that you want to do. But the idea here is when I'm testing locally, I'm going to most likely build it and run it all in one stretch. So there is something cool about VS Code is you can actually use a Docker extension. So if you look for extensions for Docker, and then you can remotely connect and remotely build into Docker. So you could actually code in Docker with VS Code. That's outside the scope of what we're doing here. But there you go. So we now have pretty much everything we need to do to then now deploy it onto some sort of container running service. Now, my intuition was, hey, can I bring this to Google Cloud Run, which is a serverless application. Unfortunately, Jupyter and serverless, I don't think work yet, because Jupyter needs a kernel that's constantly running. It needs a server actually running to work correctly. So unfortunately, Cloud Run is not a viable option, which is why I'm going to be using, of course, Heroku. And the biggest assumption I have to make is that you have the Heroku command line interface installed or the Heroku CLI. If you don't, definitely go ahead and Google how to install that. It's really easy. So we're going to go ahead and do Heroku create, and I want to create an application. So me just calling Heroku create will give me some random URL here. You can obviously declare the one that you want, but I'm just using a random one because this is fairly random of a project. Okay. So this is now the URL that I actually want to use inside of my Jupyter configuration. Right, so I had this allowed origin here. Let's bring that new one in here, protected journey, so on and so forth. Okay, so now that we've got that, what I want to do then is also run Heroku container login. So this is a command to allow Docker and Heroku to work together to actually do the pushes that we need. So it's kind of a double login. Usually when you actually download the Heroku CLI, you will also have to log into Heroku itself. So after we have this, it's just a matter of pushing and releasing this to Heroku, which is pretty simple. So we are going to call Heroku container push web. Hit enter. Now in my case, it's asking for an app because I didn't actually set up Git for this particular project. So I just need to pass in the -a and then the app name itself, which in my case, it's this right here, protected journey, right? So again, like when I do the build commands that we did before, right? The build sh, I also want to do the Heroku commands, which in this case, I'll just call it push, which is going to be that right there. Okay. And then the next one, after we push it, we just release it. Okay, so notice that it has web. So this is a web process. This is a standard Heroku thing. What that's actually looking for is this Docker file here. There's ways to have more than just web on there, and there's ways to customize the Docker file itself, but that's outside the scope of what we're doing here. Okay, so now that I have push, or of course if you're on Windows, it's going to be push.ps1. Okay. We want to Mac and Linux users, we've got to do chomod +x scripts/push.sh and then run scripts/push.sh. Okay, so I need to make sure I save everything, of course. And notice that my virtual environment is not currently activated. However, it's still building this project. The cool thing about this is it's actually building that container image and then pushing it into Heroku's container registry, where it kind of stores all of your containers related to all of your projects. And then finally, after you actually do all that, it's going to run all of the building, as we've already seen from Docker, and then we are going to actually release it. So once you actually release it, then you can actually now use what that is, which I finally did. This actually took some time to do. But if you want to know a little bit more about how Heroku runs this, take a look at this link right here. That will certainly show you a lot more of the options that you have from Heroku to actually put these things into production. Now, you may remember I said earlier that this was much more about putting Jupyter and Docker together, and then adding Heroku was sort of a bonus here. So what we can do is just run Heroku open, and oh yeah, we need to pass in the app name, which in my case is just this, random string here. And so this will open up that Jupyter Notebook Server, and we go ABC, which is the password I had, which of course now I have load and unload here, and I can actually run this, right? So let's go ahead and call this load. We run that, and all it does is basically just reload this same file. Of course, this exact same concept can be used for any additional notebooks that you might want to bring on to this server itself. This is not going to be the fastest server ever because I didn't provision any resources to it. I just made a free one altogether. It's not that big of a deal. Okay, so that is pretty much it for the baseline of things. Now, if we actually want to go a little bit further, we would actually want to add in additional resources, as in additional installations, additional packages that we might need for this particular project, which is something I certainly want to do. All right, so go ahead and go to this link right here. At the very bottom, we have this bonus installs here. We also have this code on our repo as well, but I want to actually install a few other packages for my project and just show you essentially how easy it is to upgrade your environment for your notebooks. So what we want to do is actually install things like NumPy, Pandas, OpenCV, or TensorFlow, because oftentimes when we want these more advanced packages, it's really easy to install them. And then for machine learning packages, we can do inference for sure on a CPU. It doesn't actually need a GPU to do inference or predictions. We can just use the result of that. And then there's other packages like scikit-learn that don't necessarily need a GPU to actually run well on a CPU as well. So this actual Docker file installs a bunch of stuff. So if you copy this, and we're going to bring our old Docker file in here, I'm just going to rename our old one as dockerfile.og. And if you do .og, you still get syntax highlighting inside of VS Code. And then I'll go ahead and create another Docker file or a new Docker file and paste this in here with all of the things that I just mentioned. Okay, so we can go line by line and have the things that we want and the things that we don't want, or you can just have all of this. So this command right here, this apt-get update install, this is Linux level things that are being installed. So these are Ubuntu dependencies that are system-wide dependencies that we just need in here. The biggest notable one is the OpenCV one. So if you wanted OpenCV to work on this actual project, this would be the way to do it. And there's a number of other things that you could add in here. I think earlier I talked about using curl on that terminal. You could just add in curl like that. Actually, this might be the call itself. You'd actually need references. You know, I forget the exact apt-get installs all the time. So it's easy to just look them up. In this case, I did that for you. I looked all these things up. A number of the Python 3 things we probably don't need. Git, if you need version control, there's how you can actually install it. And then inside of your Python packages, you can use something like Git Python to have Python doing all the Git calls for you instead of needing to write shell commands if you don't know how to do that. But this right here will actually install a bunch of different things related to computer science, or even to machine learning, data engineering, data science, all of that stuff, Keras, TensorFlow. It's really great. Now, OpenCV contrib Python is also being installed in conjunction with libopencv dev. Now, I've found that this is the best combination to make OpenCV work for sure if you are interested in that. Scikit-learn, another great machine learning package that you might use. But now, this is what I love about Docker files, is now you now have the Docker file to install all of this stuff wherever you need them to be installed. Right? So if you ever need this on any other project, you totally could. I just think it's very fitting for a Jupyter Notebook. So how do I actually do this now? Well, what you could do is just run scripts push. And what this should do is actually go through our new Docker file now, right? As it's showing you right here. And so it's not necessary that you have to install these things locally for your environment. As you should see now is there's a lot more installations that are happening on here that you might end up needing to do. I said Ubuntu, it's actually Debian. That just a little mistake, just a different Linux distribution, not that big of a deal. But if we scroll up, we can also see some of the recommended packages that it's telling you to do. recommended packages right here. So all of these, if you were so inclined, you could add as an item in this list that I already have here. You don't have to do that, but they are recommended by Debian in this case for the installation. And then all the new packages that are being installed for us, like GCC. Every once in a while with, I think it's OpenCV, you get this GCC error. This solves that. So that, if you've ever spent any significant amount of time trying to install OpenCV, this script and Docker makes it dead simple for OpenCV in particular. PyTorch is another one of those things that, yeah, every once in a while you're going to want to install it. And it is additional installations than just a simple TensorFlow is a lot easier to install than PyTorch is. But of course, adding the GPU adds a layer of complexity that I'm just not going to cover here. But as you see, we've got another apt-get call in here. Really, when I actually build these things, I put all of the apt-get calls together. I don't actually separate them out. But I wanted to leave notes in here for you depending on what you wanted, right? So you could get rid of that. And of course, if you're using fast AI, you definitely need PyTorch installed. But this, I think, is really cool for inference. Now, the other aspect of this that I want to mention is our little load unload command. This will work for models as well. So if you had pickled model files or any other kind of model file, H5 model file, you can use this exact same thing. It will load everything up, and then you can unload it once you get into the server. And when you actually build your container image, this tar file will be able to come with you. So as it relates to Heroku, is you now don't have to worry about the slug size as you would not using Docker. So if you actually deploy Jupyter as a standard Heroku application, a non-Docker application, you'll run into a lot more issues with installation because of the size of things. Docker, as far as Heroku says, there's no size limit, which is another benefit to using Docker. There's just too many to count. Okay, so this is going to take significantly longer to actually update and install because I've added just so many things here. I'm actually not going to finish adding this. I just wanted to mention this as a really valuable option for later. And of course, if you install this Docker file on your local system, it's gonna eat up a lot of resources, which is why I started out with just saying, hey, let's just do this slim version because that's the bare minimum of what we need, and then we can add the things that we want later. All right. Hey, thanks so much for watching. Hopefully you got a lot out of this in the sense that you now have complete control over a Jupyter Notebook Server. Now, me personally, I actually use the Google Colab all the time. So that's actually my default for Jupyter Notebook Servers at this point. There's a lot more advantages to just spinning that up than this. But for those of you who want that granular control or just to learn how to know more things, this was a really good example of that. I actually think learning this or going through this process is important to better understand both technologies, that is Jupyter and Docker. And of course, there's the added bonus of using Heroku to actually get it into production. But the main thing here is to understand that Docker and Jupyter are amazing combinations. And I actually think that in the near future, we'll see a new service out there somewhere that allows this combination to happen, and then spinning up our own GPU where it costs practically nothing or next to nothing, so that you might actually switch back to something like this than Google Colab, because Jupyter is still pretty young as a package, and I think there's going to be a lot more cool and interesting services that come out as a result. So of course, if you actually find any, please comment below, because I would love to check those out, like essentially turning this into the same power that Colab has, and maybe even overcoming some of the challenges of the ephemeral nature that Docker combines. So maybe one of those things being persistent volume, something that Heroku does not have by default for containers. But anyways, thanks again for watching. I hope you got something out of this, and I look forward to seeing you next time.